Hi guys, this is lesson 2 in unit 5. We're going to talk about domain versus range and rate of change. Let's find out what the words domain and range mean. The domain of a function is the set of all possible x values that we named inputs before, which will make the function work and will output real y values. The range of a function is all possible y values, outputs of a function that result when we substitute all the possible x values into the function. So let's find out what that means. Let's take a look at our first example where we have a relation set. We have 2, 3, 3, 4, and 4, 5. We said that the domain is the set of all possible inputs. So in this case, the inputs are 2, 3, and 4. And this is exactly what our domain for this relation set is. It's 2, 3, and 4. These three values. Now, we also said that the range of a function is all possible y values or outputs that result when we substitute the inputs into the function. So now the output for 2 is 3, the output for 3 is 4, and the output for 4 is 5. And these outputs are what we call the range of this function. Let's take a look at our second example where we have a map diagram. In the map diagram, we see the arrow going from 7 to 7, from 8 to 7, and from 9 to 8. So this tells me that 7, 8, and 9 are the input values which make the domain. And the output values are 7 and 8, which make the range. Our third example is a graph, where we have a graph and we're trying to find the domain and range for the function represented by this graph. Now, to be able to find the domain, I need to identify all the x values that goes into this function. So to be able to identify the domain, I need to count all the possible x values. For that, I'm going to use a vertical line that cross the graph from the left to right, which will tell me that our x values start at 0 and it doesn't end. It goes forever, which means that the domain for this function starts at 0, including 0, and doesn't end. That means it goes to infinity. Now, to find the range of this graph, I need to do the opposite. I need to use a horizontal line that goes from the bottom of the graph to the top of the graph to identify all possible y values, all possible outputs for the inputs that we have in this graph. So if I move a horizontal line across the graph, I see that I'm including all possible y values in this graph or all possible outputs on this y-axis. That means that the range goes from negative infinity to infinity. Let's take a look at our fourth example. So in this example, we have a table of values. We have negative 2, 5, 0, 5, 2, 5, and 4, 5. So the inputs are all, or the domain is all the possible inputs in this example. So in this case, the domain is going to contain negative 2, 0, 2, and 4. The range is all possible outputs for these inputs, which is in this case just one value, which is 5. Stop the video right now, finish the first page of your class practice, and then continue with the video. Now we're going to talk about the average rate of change. And we talked about the average rate of change before when we talked about linear equations and slopes. And we said that the rate of change is equal to the slope, which is equal to the difference in y over the difference in x. In functions, the average rate of change is the difference in the outputs divided by the difference in the inputs. So the only difference between the formulas is how we write down the top part of the fraction here. So in equations, we talk about the difference in y, and in function, we talk about the difference in the outputs. So again, in functions is the difference in the outputs, and in equations, it's the difference in y. So let's find the average rate of change for a function over an interval when we have a graph. And the interval that we have here is for every single input between -3 and 0. So my focus on this graph should start with -3. That's the start of the interval right here. And this point is -3, 0. -3 is the input, 0 is the output for -3. And it ends at x equals 0. X equals 0, which is right here. And this point is 0, 3, so the input is 0 and the output for 0 is 3. We talked about the average rate of change. We said it's the difference in f of x divided by the difference in x, which means I need to find the difference between the outputs divided by the difference between the inputs. So I'm going to have to look at the difference between the outputs of 0 minus the output of -3 divided by 0 minus -3. If we look at the output of 0, which is in this case right here, the output of 0 is 3. And the output of -3 is right here, which is 0. So I can switch these two notations with 3 minus 0, which make me end up with this final answer. Now we learned how to find the slope or the rate of change before for a line looking at a graph using rise over run, and we can definitely use the same thing here. If we look at this interval or this piece of the graph and try to apply the rise over run, we're going from x equals -3 from this point right here to this point right here, which is the end of the interval. So I'm going up 3 points, that's the rise, and I'm going across to the right 3 points or 3 units, which is the run. So at the end, I'm going to end up with 3 over 3, which is going to give me the same answer as my formula, which is 1. Now let's find the average rate of change for a function over an interval looking at a table. And again, we're using the same formula, this time over an interval of every single input
between 2 and 4, including 2 and 4. That means that my interval starts at this point where x equals 2, and it ends at this point where x equals 4. So again, I'm using the formula. It's the difference in f of x divided by the difference in x, which means I'm going to have to find the difference between the outputs of 4 and 2 divided by the difference between 4 and 2. Now, the output for 4 is what we have right here, which is the y value of the 4, which is 16. And the output of 2 is 4, which is the value that we can find here in the table. So I can switch the notation of f of 4 minus f of 2 with 16 minus 4. And if I solve the whole expression, I'm going to end up with 6. And again, in the past, we talked about how to find a slope, or the slope value, looking at a table by using the difference in y over the difference in x. And we can definitely use the same thing here. We need to find the difference in y, which is in this case 16 minus 4, which equals 12, and then the difference in x, which is 4 minus 2 equals 2. We end up with the difference in y, which is 12, over the difference in x, which is 2. So we end up with the same answer as the answer we got using the formula. Finish your class practice now.